In this lesson, we're going to express quadratic expressions into the completed square form. We are given x squared plus 8x plus 10, and in the second example, we are given x squared, x plus p squared plus q. We are required to find the values of p and q. Now, to do this, we're going to consider only the first two terms of the expression we were given of x squared plus 8x plus 10. In those first two, we will aim to make them a perfect square. Now, usually to do that, you will take the coefficient of b divided by 2 and square it. Remember, the standard quadratic equation is ax squared plus bx plus c. So in this case, our b is actually 8. So we're going to add half of 8 squared to x squared plus 8x. Now we've come up with a new constant, which is 8 over 2 squared. Initially, we had a constant of 10. 8 over 2 squared actually gives us 16. So to reduce that to 10, we subtract 6 so that we do not change the question. Now, 8 over 2, we know clearly that gives us 4. So we do have now x squared plus 8x plus 4 squared minus 6. That expression of x squared plus 8x plus 4 squared is actually a perfect square, and it can be written in a simpler form of just being x plus 4 squared. We don't forget to subtract 6 to remain with the expression that we were given at the beginning. And so we now have x plus 4 squared minus 6. That is our completed square form of the quadratic expression that we had of x squared plus 8x plus 10. Now in part B, we equate our solution of x plus 4 squared minus 6 to what we were required to find of x plus p squared plus q. Now it's quite easy to read off the values of p and q. Where there is p, you can see clearly there is 4. And where there's q, you can see there is negative 6. So our solution for p and q is simply p is 4, while q is negative 6. In this example, we are required to find the completed square form of 4x squared plus 6x plus 10. And after that, find the values of m and n in the quadratic expression 4 into x plus m squared plus n. Now to do this, we're going to look at only the first two terms and attempt to complete the square so that we have a completely new expression. Now we first of all start by making x squared to have a coefficient of only 1. And that is only possible by dividing 4x squared by 4 and dividing 6x by 4. So we're going to put that 4 outside the brackets. So we have 4 into x squared plus 6 over 4x plus 10. Let us complete the square for the term inside the brackets. That is x squared plus 6 over 4x. To do that, we add half the coefficient of x squared. That is going to be multiplied by 4, and after that we are required to add a constant. And the constant this time has become 6 over 8 squared. Now, because the constant has changed, remember the constant initially was 10, but we already have 6 over 8 squared. We're going to have to work out the new constant to add outside the brackets, and that is 7 3/4. Let me show you on the sides how to find that 7 and 3/4. Now, first of all, the 4 was being multiplied into that constant of 6/8 squared. Remember, 6/8 can be 3/4. We add some constant that we do not know so that we get 10, the original constant. 3/4 when squared becomes 9/16, and when you multiply by 4, we get 9/4. So 9/4 plus that constant that we do not know will get us to 10. To get that constant, we call it W in this case. We do 10 take away 9/4, and that gives us 7/3/4. I hope you've understood how we found that a new constant of 7 and 3/4. Now back to the question, that we do have that term inside the brackets, which is actually a perfect square. We can express it in the form a plus b squared, and that becomes x plus 6/8 squared multiplied by 4 plus the 7 and 3/4 that we found on the side. Clearly, that term has already been expressed into the completed square form. We can only do simple simplifications, 6/8 to become 3/4, and that gives us our final answer. Now, we are required to find m and n in the second part of that question. We're going to equate this solution that we've just found to what we were given as 4 into x plus m squared plus n. And clearly, where there is m, you can see we do have 3/4, and where there is n, we do have 7 and 3/4. Those two are our final solutions for this question. Thank you for watching this. Please share and subscribe. It's your teacher, the Math Rabbi.